21, find y prime. Alrighty, since there are parentheses, we're going to go ahead and do a u substitution. So I'm going to let this be u, so we'll just actually have y equals u to the fifth. And then when I go to take the derivative, I will get 5u to the fourth times the derivative of u, and the derivative of u would be 9x squared. So, simplifying this a little bit, my 5 and my 9 would get put together to become 45, and then I've got x squared, and then I'll replace my u back in, so u is 3x cubed plus 2, and it's raised to the fourth power now. So that would be y prime. Alrighty, number 22, discuss the concavity of this function. To discuss the concavity, we definitely need to get to y double prime. So let's get to y prime first. The derivative would be 4x cubed minus, if I bump that 3 out in front, these 3's are going to cancel, so I'll get 13x squared minus 16x. And then y double prime will be 12x squared minus 26x minus 16. If I want to find a critical number, I'm going to take that second derivative and set it equal to 0. That looks like an awful problem to try to factor, but I do know that I could divide a 2 out of both sides of my problem, and if I do that, I will get 6x squared minus 13x minus 8 is equal to 0. From here, I'm going to apply the magic number trick, so I'm going to start with 2 parentheses. I'll put 6x, 6x, knowing that when I'm done, I'm going to have to divide out that extra x that I put in there already. Then I always take the first number times the last number, which gives me negative 48, and then I think to myself, what times what would give me negative 48? Negative 8 times 6, negative 12 times 4, negative 16 times 3, and I could keep going. I want to know which one of those options would give me that negative 13 in the middle. It's going to be this third one that I wrote, so it will be minus 16 plus 3. I do know that I need to divide the 6 out. I notice I can't divide the 6 out of each one, so I'm just going to split this one up. I could divide the first one by 2 and the second one by 3, and notice that does make 6. So if I divide the first one by 2, I'm going to have 3x minus 8, and if I divide the second one by 3, I'm going to have 2x plus 1. Okay, if I set that equal to 0, if I set each part equal to 0, this will give me x equals 8/3. If I set this second part equal to 0, x will equal negative 1/2. So on my y double prime chart, I am going to have negative 1/2 and 8/3. Okay, from here I'm going to plug, I think I'll plug like negative 2 into y double prime. If I do that, I will get a positive value. Next thing, I'm going to plug 0 into my y double prime. That will give me a negative number. And then if I plug in like 4 or something like that into my second derivative, I will get a positive number. So if I would like to discuss the concavity, I would say that y is concave up from negative infinity to negative 1/2, and then it's also concave up from 8/3 to infinity. And as long as I'm discussing, I would say that would be because y double prime is positive. And then y will be concave down on the interval negative 1/2 to 8/3, and that would be because y double prime is negative. Okay, problem 23, it says to find f of g of x. This is a composite function, so basically what I'm going to do is I'm going to plug g of x into f of x. So I'm going to take whatever I have for g of x, and I'm going to plug it in for the x in f. So I'm going to have f of g of x will equal square root x squared minus 9. I cannot go any farther than this. I'm going to show you that I cannot do x minus 3. That is a big no-no. You'll be breaking the math law if you do that. Okay, 24. I have cosecant x to the cosecant fifth of x, and we would like to find y prime. If I were to type this in my calculator, it would be rewritten as in parentheses cosecant x, and it would be raised to the 5th power. So if I'm taking the derivative, I'm going to have to use the chain rule, so I'm going to turn this into a u problem. So if I take the derivative, that would give me 5u to the 4th times the derivative of the u, and the derivative of the u would be negative cosecant x cotangent x. Hopefully you know those formulas. Okay, my last step is just to sub in my u. I am going to put the negative out in front of the problem because that's the proper place to put negatives. So I'll get u to the 4th, so it will be cosecant to the 4th x, cosecant x, cotangent x, and then I notice that I can put these two together to make it negative 5 cosecant to the 5th x, cotangent x, and that is my derivative. Okay, 25, find the absolute maximum of this function on the interval negative 2 to 4. The biggest thing, the absolute maximum, is going to be the biggest y value that I will get on this interval. So if I want to find a maximum, I first of all take the derivative. So I'm going to take the derivative. When I take the derivative, I'm going to get x cubed minus 6x squared, and that is it. I next would like to find the critical number, so if I set the first derivative equal to 0, I think I will factor out an x squared, which would give me x minus 6. So my two critical numbers will be 0 and 6. And then if I look at my interval goes from negative 2 to 4. 6 is not on the interval, so I do not even need to consider that. Okay, if I'm doing absolute, I do not make an f prime chart. Instead, I want to evaluate, because I want to find y values. I want to find the y value at the critical number, but I also would like to find the y values at the endpoints. Okay, so if I plug in 0 into the original function, I will get 7. If I plug negative 2 into the original function, I will get 27. And if I plug the original, the 4 into the original equation, I will get negative 57. All right, so if I'm looking for the absolute maximum, I'm looking for the highest y value. So the highest y value would be 27.